All right. So, here I have a quadrilateral, a four-sided figure, inscribed in the circle. Okay? Here I have a quadrilateral inscribed inside the circle. Okay? Let's do this. I'm just going to do this with marker here. Let's say this right here is 70 degrees, right there. I'm just saying for example. Okay? If that's 70 degrees, what do you know about the arc BD? 140, right? Okay? So the measure of the arc BD has to be 140. Everybody agree with that? Is that logical? I'm trying to get somewhere so you don't have to memorize this rule. It should make sense to you. Everybody's okay with this?
Yep.
Okay. Then, yes. 20 is fine. The actual test 70. Now, how about the arc, the measure of the arc BAD? What would that have to be, Andy? But an actual number.
220.
220? You agree? How'd you get that?
Because you subtract 140, which is what you had of BD, and you subtract that from 360, which is what the whole circle is, and you get 220.
Nice. BAD is this part. So if that's 140 and the whole thing has to make 360, well, if here's 140, take 140 away from 360 and you'll get that 220 number, right?
Yes.
Alright, well then, if the measure of the arc BAD is 220, tell me what the measure of angle C would have to be then. What would the measure of angle C have to be? 110. 110. Yep. Because this angle intercepts the arc, that's 220, so therefore that one has to be 110. What do you notice about these two angles in this quadrilateral, these opposite angles? What do you know about them? Notice about them? They're supplementary. They add up to 180 degrees. That will always, 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 always be the case when you have a quadrilateral inscribed in a circle. Opposite angles will always be supplementary. You can either know that rule or just use the rules we've already talked about earlier today and figure it out, because you guys just figured that out on your own here without knowing this new theorem or whatever. Okay? It should make sense because this angle opens up to part of the circle. This angle would open up to the other part of the circle. Well, we know that the entire arc is 360, so then those two added together, since they're half, inscribed angles are always half, they would have to add up to 180. Alright, so that's kind of the last theorem. So they might give you a problem like this. Could you solve that for x and y?
Yeah.
If you know that rule, what would you set up? Antonio?
268 plus 3y equals 180.
68 plus 3y equals 180. Good, because we know opposite angles always have to be supplementary. And you guys know how to solve that. I'm not going to waste your time solving a two-step equation here. Well, how about to solve for x? Somebody different. Brett?
2x plus 82 equals 180.
Yeah, 2x plus 82 equals 180. Okay? If you have a quadrilateral, a four-sided figure inscribed in a circle like that, opposite angles will always be supplementary. So you know that those have to add up to 180, so write that. 68 plus 3y has to add up to make 180. 2x plus 82 has to add up to make 180. And you'd be able to solve for the variables. Okay? Simple enough? Alright, you're good?